Hello friends, I welcome you in lecture number 16 on hypothesis testing. In this lecture we will discuss one question on large sample test for a population proportion. We have discussed about test statistic for this large sample test in lecture number 15, and if you recall, in that lecture we have seen that the test statistic for population proportion is Z equal to sample proportion P hat minus population proportion divided by square root of P times 1 minus P divided by N, and if this condition is satisfied, then this Z is approximately a standard normal random variable, and sample proportion is given by capital X by N, where capital X is the number of elements having specific characteristic and N is the sample size. So with this in mind, we try to answer this question. A manufacturer of submersible pumps claims that at most 30% of the pumps require repairs within the first 5 years of operation. If a random sample of 120 of these pumps includes 47 pumps which required repairs within the first 5 years, test the null hypothesis that population proportion equal to 0.30 against the alternative hypothesis that population proportion is greater than 0.30 at the 0.05 level of significance. So first thing we have to decide is what is the population, what is the characteristic of the population with which we are talking in this question, what is the sample size, what is the sample proportion. All these things we must decide before going for answering this question. So here we can consider population as the set of submersible pumps manufactured by some manufacturer, and we are interested in the class of those pumps which require repairs within the first 5 years of operation. Now manufacturer claims that at most 30% of the pumps require repairs. That is, if we consider the population of all submersible pumps, then at most 30% pumps require repairs. That is, we are given the population proportion. Manufacturer claims that at most 30%, that is maximum value for population proportion is 0.30. So this is the claim of manufacturer that population proportion can be at most 0.30. That is, the portion of the population which require repairs is maximum 0.30. And to test this claim, a random sample of 120 pumps is tested, and it is found that there are 47 pumps which required repairs within the first 5 years. So we have a sample size 120, and we have 47 pumps requiring repairs within the first 5 years. That is, capital X is the number of pumps which required repairs from that sample. So that number capital X is 47 here. So from these two values we can decide the sample proportion P hat. We can find out the fraction of the sample which is requiring repairs within the first 5 years. So first we have to state null and alternative hypothesis, but here they are already specified in the question. We have to test the null hypothesis that population proportion is 0.30 against the alternative hypothesis that population proportion is strictly greater than 0.30. So we just write down whatever is given. Null hypothesis is given as population proportion is 0.30, and alternative hypothesis is population proportion is greater than 0.30. some sources consider this as p less than or equal to 0.30 also. So that is also correct, but we are always considering this type of null hypothesis, equality statement in the null hypothesis, and this is negative of this statement. So here we are given this null and alternative hypothesis. So we assume that null hypothesis is true. Also we are given the level of significance, which is alpha equal to 0.05. We are taking a sample of 120 pumps, and the number of pumps which required repairs in this sample is given as 47. So we can find out value of sample proportion, which we denote by p hat, that is going to be capital X divided by n, and here I have 47 divided by 120, and this turns out to be 0.3917. Now once we have sample proportion and population proportion, we assume that null hypothesis is true. So we will consider population proportion p equal to 0.30. So once we have all these values, we can find out the value of test statistic, and before applying that test statistic, we have to check this condition, that whether we can apply that test statistic or not. So for that we find out this n into p. What is n? N is 120, and what is value of population proportion? It is 0.30. So let me calculate this product, and it turns out to be 36, and it is greater than 5. Similarly, I have to calculate n times 1 minus p. N is 120, 1 minus p, that is 1 minus 0.30 is 0.70, and let me use my calculator to find out this product also, and this turns out to be 84. This is also greater than 5. So because n times p and n times 1 minus p both are greater than 5, we can apply the test statistic which we have discussed in lecture number 15 on hypothesis testing on population proportion. So now we see what is our test statistic. It is z equal to sample proportion, that is p hat, minus population proportion divided by square root of p times 1 minus p over n. If this condition is satisfied, then we have discussed in lecture number 15 that this z is a standard normal random variable, so that we can apply one sample z test here also. Now next step is to find out the value of test statistic. So for that we substitute all these values here. What is sample proportion? P hat is 0.3917, so that I substitute here 0.3917. Some population proportion, small p is 0.30 divided by population proportion, that is 0.30, into 1 minus 0.30, that is 0.70, divided by sample size, which is 120. And I am doing all these calculations by fixing my calculator up to 4 decimal places. So the difference in the numerator is 0.0917, and if I consider product of these two quantities and divide by 120, I obtain 0.0018 up to 4 decimal places. Now I write this as it is, and square root of 0.0018 turns out to be 0.0418, and finally we obtain the value of test statistic by taking division of these two numbers as 2.1938, or we can round off up to 2 decimal places, it is 2.19. This is the value of test statistic, 2.19. Now next step is to decide the critical values. So for that we note that level of significance is 0.05 and the alternative hypothesis is p greater than 0.30. That is, we have upper tailed or right tailed test. This is one-sided alternative. So we have upper tailed test, and this capital Z is a standard normal random variable. So therefore our distribution follows standard normal distribution. So for that, let me sketch this roughly bell-shaped curve of the distribution. Our underlying distribution is a standard normal distribution. So we have this bell-shaped structure for that capital Z, and level of significance is alpha, and we have right-tailed test. So we consider this area in the right tail, and this is Z suffix alpha. Alpha is 0.05 here. That is, area in the right tail is 0.05, and in the center we have Z equal to 0. Now we know that here area to the right of this Z suffix 0.05, if we consider this Z suffix 0.05, then this area is 0.05. So from this I can decide the area to the left of this point, 0.05. This is going to be 1 minus 0.05. That is nothing but 1 minus 0.05 turns out to be 0.95. So now I am having this cumulative probability that Z is less than this value, Z suffix 0.05 is 0.95. So I am interested in this value of Z such that this area is 0.95 or this probability is 0.95. So that I can find out using the cumulative standard normal probability table. So in that table I have to search for 0.95, and I have to decide that which value of Z corresponds to this area of 0.95. So here we have standard normal cumulative table, and we know that if we have this point as Z, then area to the left of Z is probability that Z is less than or equal to Z. So we are given the values of different areas here which are to the left of small z, and we are interested in the area 0.95. So I will search for 0.95 in this table. So let me search for 0.95, and here we can see, here I have 0.9505 and here I have 0.9495, and both are near to 0.95. So I can go for this value of Z. Here I have 1.6, and corresponding to this I will have 1.64, and corresponding to this I will have 1.65. So I will take average of 1.64 and 1.65 to find out the corresponding value of Z. So this turns out to be 1.645. So that means if we consider probability that Z is less than 1.645, then it turns out to be 0.95. So critical value of Z, this value is nothing but 1.645, or we can write that average of 1.64 and 1.65 divided by 2. Therefore Z suffix 0.05 is 1.645. The critical value for Z is 1.645. Now we compare this critical value with value of test statistic. Value of test statistic is 2.19. So we can see 2.19 is to the right side of this 1.645. Suppose somewhere here we have 2.19, then test statistic is greater than Z suffix 0.05. So we are in the rejection region. So this means we reject the null hypothesis.